longest rectangle in histogram. In this, we have given a array of heights and we have to return the maximum area. In the diagram, we can see that 5 is occupying the maximum area which is 10. So this 10 is the maximum area. So before writing the code, let's understand the approach. Largest rectangle in a histogram. इस कोड में दो क्या क्या ऑक्यूपाई कर सकता है. इधर तो कोई जगह है नहीं, इधर जो है उससे कम है. सो दो मैक्सिमम एरिया ऑक्यूपाई कर सकता है विच इज 2. फॉर वन एक ये ऑक्यूपाई कर सकता है, ये ऑक्यूपाई कर सकता है, ये वाला रीजन ऑक्यूपाई कर सकता है, ये वाला कर सकता है, ये वाला कर सकता है. सो द एरिया इट विल ऑक्यूपाई इज 1 2 3 4 5 6. 6 into its height means 6 area it can occupy. For 5 इधर ऑक्यूपाई नहीं कर सकता क्योंकि इधर छोटे ब्लॉक्स हैं. अगर वो इधर ऑक्यूपाई करेगा तो ये इधर ऑक्यूपाई नहीं कर सकता. तो मतलब 5 क्या क्या ऑक्यूपाई कर सकता है, जिसकी विड्थ है 2 और हाइट है 5. सो 5 10 यूनिट एरिया ऑक्यूपाई कर सकता है. फॉर 6 इधर ऑक्यूपाई नहीं कर सकता क्योंकि छोटा ब्लॉक है. इधर भी ऑक्यूपाई नहीं, 6 इधर भी ऑक्यूपाई नहीं कर सकता क्योंकि छोटा ब्लॉक है. सो एरिया कवर्ड बाय 6 इज 6 यूनिट. इस दो के लिए ये इधर एरिया ऑक्यूपाई कर सकता है और इधर एरिया ऑक्यूपाई कर सकता है, जिसकी लेंथ है 4 और हाइट है 2, मतलब 8 एरिया. फॉर 3 इधर एरिया ऑक्यूपाई नहीं कर सकता, ना ही इधर ऑक्यूपाई कर सकता है क्योंकि छोटे ब्लॉक्स है. सो इससे जो एरिया होगा वो होगा 3. सो मैक्सिमम एरिया 10. सो और फर्दर देखते हैं डीप में. सो फॉर हियर अपन इंडेक्सेस देंगे जिससे और क्लियर समझ में आएगा. सो -1 मीन्स कुछ नहीं, previous block of the first block 0 1 2 3 4 5 6. 2 के लिए एरिया निकालने जाए तो एक इधर कुछ नहीं है, इधर कुछ नहीं है, मीन्स इसकी बाउंड्री कंडीशन लेफ्ट बाउंड्री और राइट बाउंड्री 1. सो इसका एरिया बनेगा राइट बाउंड्री माइनस लेफ्ट बाउंड्री मीन्स विड्थ -1 means here it will be 1 2 -1 1 means length is 1 and height is 2. So height into width is 2. For 1 इसकी बाउंड्री कंडीशन क्या है, लेफ्ट बाउंड्री 0. For 1 left boundary will be -1 and the right boundary will be, here it can occupy the area, the right boundary is 6. So 6 minus left boundary -1 will be the width. What will be the width then? 6 will be the width and height is 1. So the area which will cover is 6. For 5 what will be the left boundary? 5 can't occupy this, means the left boundary will be 1 and the right boundary will be 5 can occupy this, so the right boundary will be 4. So right boundary minus the left boundary -1 means 2. This is the width, as we can see 2 is the width and the height is 5, so 10. For 6 what will be the left boundary? As this can't get occupied, so the left boundary is 2 and the right boundary will be 4. So the width is 4 minus 2 minus 2, 4 minus 1. So the width will be 4 minus 2 minus 1 will be 1. So the width is 1. So 6 into 1, the area will be 6. So the formula we can calculate is that right boundary minus left boundary minus 1. So width is equals to right boundary minus left boundary minus 1, and the height of I, if we multiply, we can get the area. So in this problem we want maximum area, so we can use the max function over here. So for this, let's calculate the maximum area by using this formula. So first make the indexes minus 1, 0, 1, 2, 3, 4, 5, 6. For 2, what will be the left boundary? For 2, the left boundary will be minus 1 and the right boundary will be plus 1. For 1, what will be the left boundary? It is minus 1 and the right boundary will be this 6. For 5, what will be the left boundary? It will be 1 and the right boundary will be 4. For 6, the left boundary will be, for 6 the left boundary will be 2 and the right boundary will be 4. For this 2, the left boundary will be 1 and the right boundary will be 6. For 3, the left boundary will be 4 and the right boundary will be 6. So according to the formula, right boundary minus left boundary minus 1, this will get the width. So subtract it minus 1. So it will be 0, it will be 5, it will be 3, it will be 3, it will be 5, it will be 5. So, and we have to subtract right boundary minus left boundary. So width will be 1, 6, 2, 1, 4, 1. So, and the height correspond to it means these are the heights. So the heights are 2, 1, 5, 6, 2, 3. So we will calculate the area. This will get area 2, the area will 6, 10, 6, 8 and 3. So what is the maximum area? 10 is the maximum area. That's how we will calculate the area. So check how we will calculate the left boundary and the right boundary. This is the algorithm for left boundary. We have to start the loop from I starting from 0 up till n. Then we will have to check this, and we have to do this state. So for starting, we will have to initialize the ANS vector with -1. Of size n. Zero, 1, 2, 3, 4, 5, and our original vector, which is 2, 1, 5, 6, 2, 3. For O of 1 time complexity, we will have to use stack. So this is our stack. So I starting from 0 means I is pointing here. The stack is empty, so this is not done. This case is violated, so move on to the next case. This is also violated, So push I means push the index 0. So I is incremented here. Check this condition. First is good and the second is height of s dot top. S dot top means height of 0. Height of 0 is 2. 2 is greater than or equal to height of I 1. It is true. Yes, it is true. It is true. Yes. So we will have to pop this. So we can also see that 5 on the left hand side, 2 and 1 both are smaller than 5, but for the value which is close to 5, the value जो 5 के नज़दीक है मीन्स 1, वो कंसिडर की जाएगी rather than this value. So we will have to pop this. After popping this, we will have to check this. Stack is empty, so this is violated. So st.push.I, we have to push this I. So 1 is pushed. Again check. I will be here. It is not empty. Then height of s dot top means height of 1. Height of 1 is 1. Is greater than or equal to height of I means 5. Is it true? No. So this condition is false. So we will have to come to 2. It is not empty. So ans of I means in ans I is 2. So ans of 2 is equals to s dot top. So for ans of 2 we will have to make it equals to the top. So we will make it 1. And we will have to push that index also. So index 2 is pushed. So I will come up to here. So it is not empty and the height of top. Height of top means height of 2. Height of 2 is 5. 5 is greater than or equal to height of 5 means 6. It is true? No. So come up to here. Ans of 5 means I is 3. So ans of 3 is equal to s dot top. So means ans of 3 will be 2. So then push the value of I means 3 is get pushed. So again I is incremented here. It is not empty and the height of top. Height of top means height of 3. Height of 3 is 6. Is greater than or equal to height of I. Height of I means height of 4 is 2. It is true? Yes. So we will have to pop. This is popped. Again we have to check. Height of top means 2. Means height of 2 is 5. Is greater than or equal to the height of I. Height of I means 4. Height of 4 is 2. It is 2. Then pop. Again check. Height of top means height of 1 is 1. Is greater than or equal to height of I 2. So this condition is false. So move on to here. It is not empty. So the ans of I means ans of 4 will be top. So ans of 4 will be top means ans of 4 is 1. And push the value of I is 4. So 1 is pushed. So again I is incremented up to here. It is not empty and the height of top means height of 4. Height of 4 is 2. Is greater than or equal to height of 5. Height of 5 means height of 5 which is 3. It is true? No. So here case will be. So come up to here. It is not empty and the ans of I means ans of 5 is st dot top means ans of 5 will be 4. And push the value of I value is pushed. So our final ans vector will be -1, -1, 1, 2, 1, 4. This is a vector of left boundary. This is algorithm for right boundary. In this, we have to start the loop from n-1 up to 0. This is the condition we have to follow. So we will have to create a ANS vector of size n, which will contains n, means the size of the main array. So we will put 6. And the main array is 2 1 5 6 2 3. We will use stack. So let's start. I is point up to here. Is it empty? Yes. Is it empty? Is it also empty? So push the index. So 5 is pushed. So again I will go up to here. It is not empty, and the height of st.top means height of 5. Height of 5 is 3, is greater than or equal to height of I. Height of I is 2. Is it true? Yes. So pop it. So it is popped. It is empty, and we have to push the index of I. Index is 4. So again run the loop. I will go here. Height of top means height of 4 means 2 is greater than or equal to height of I. Height of I is 6. Is it true? No. So come up to here. Is it not empty? So ANS of I is 3. So ANS of 3 is equal to st.top, means ANS of 3 is top, means 4. ANS of 3 is 4. And we have to push the index as well. So index is 3. So push the index as 3. So again I is minus. So I will be here. It is not empty, and the height of top means height of 3. Height of 3 is 6. 6 is greater than or equal to height of I. Means height of I means height of 2, which is 5. Is it true? Yes. So pop this. Again we will have to check the loop. Height of top. Height of top, as there is a single element, no need to check. So come up to this condition. It is not empty. So the ANS of I means I value is 2. So the ANS of 2 will be st.top means 4. So ANS of 2 is 4. We will have to put the index as well. So 2 is pushed. I come up to here. It is not empty, and the height of top. Height of top means height of 2. Height of 2 is 5. Greater than or equal to height of I means height of 1. Is it true? Yes. So pop this. So 4 is remain. Again check the while loop. Height of st.top means height of 4. Height of 4 is 2. It is greater than or equal to height of I means 1. Is it true? So pop this. So after doing this, it is not empty. It is empty. So again move to here. Put the index means 1. Again I will be here. It is not empty, and the height of s.top means height of 1. Height of 1 is 1. Greater than or equal to height of I. Height of I is 2. Is it true? No. So come up to here. It is not empty, and the ANS of I means I is 0. So ANS of 0 is s.top means 1. ANS is 1. So I is exhausted. This is the ANS. So the final ANS is 1 6 4 4 6 6. So let's code.
After understanding the approach, we have to write the code for the next boundary and the previous boundary. So let's write the code for next boundary. So vector int next boundary vector int heights. So int n equals to heights dot size vector int ns. So stored the n in this user stack. So as we have discussed in the approach, we have to initialize the for loop from the back. I minus minus. So while stack is not empty and heights of st dot top is greater than equal to heights of the current height. If this is true, then st dot pop. After this इस कोड के बाद if st dot empty, then ns of I will be st dot top. So if this is done, then push the index. After this is done, we have to return the ns character. Return ns. So now let's write the code for previous boundary. So vector int previous boundary vector int ampersand heights int n equals to heights dot size vector int v vector int ns, which contains size of n, which contains -1. So for loop start from 0. While stack is not empty and then heights of st dot top is greater than equals to heights of I. If this is true, then pop. After this code segment, if stack is not empty stack is not empty, then push the top in the NS index instead of top. After this, push the index in the stack. So after doing the for loop, let's return the NS vector. So after writing code for previous boundary and the next boundary, let's move on to the main code. So make int max area equals to 0, int area equals to 0, int n equals to heights dot size. So push the answer of the vector in this vector, means vector int next positive in this vector, push the next boundary vector. So next boundary of heights in the next vector, previous positive, push the ANS of the previous boundary. So previous boundary of heights. So both vectors are get pushed. So for int I starting from 0, I less than n, I plus plus, int width equals to next positive of I minus previous positive of I minus 1. So this is the width. So for the area, in area we will store the temporary area. So width into heights. So max area equals to the max of max area comma area. So max area contains the ultimate max area. So return the area. Let's run the code. Test cases are accepted. Let's submit the code. Code is successfully submitted. Thank you.